In the previous video, we were able to set up the solver and run it to find out our total labor cost, among other things. Let's look at the sensitivity report in this video and find out some more answers to the questions that might be important for the HR manager for whom we are solving this problem. Now, before we do that, I'm going to go over our solver setup real quick. There are some important pieces of information in our programming space, and I will be making notes. I'll encourage you to do that with me as well. Now, the first and the foremost thing we have to look at on this sheet is the total cost, which is our objective function right here. This is the total cost of employing all our people given our demand in this theme part. If you look at our yellow cells, these are the number of people who are taking the days off in the morning shift and the afternoon shift. Now, these yellow cells are important in this programming space because they give us the information about how many people are actually employed by this theme part. Now, if I have to ask you that question, the answer lies in these yellow cells. And all I have to do is sum up all my yellow cells. The answer would be 240. So this theme park right now is employing 240 people. And to make sure that I don't forget that, I'm going to make a little note right here. So sum of yellow cells is where we find out how many people are working in this theme park. Now you must be wondering, why is this sum of yellow cells? And the quick answer is, remember what the yellow cells are representing. It is representing people who are taking 2 consecutive days off in the morning shift and the afternoon shift. Now one person can only take 2 consecutive days off once in a week. So there is no repetition in these yellow cells. Hence, the sum of these yellow cells is the total number of people or employees working at the park. If yellow cells are representing the total number of employees, what does the blue cells represent? The answer is very simple. The sum of blue cells is basically the total shifts, the total number of shifts in a week. A shift is basically a collection of people with same hours to work, days off, responsibilities, and wages. Keeping that in mind, let's move on to the sensitivity report. So here is the sensitivity report for our theme park problem. I'm just going to go ahead and quickly color code and format it, and I'll encourage you to do that with me. So while we are interpreting it, it will be easier for us to follow. So the first thing I'm going to go ahead is I'm going to insert a little cell right here. We're going to start with the variable cells table. What does the final value represent? The final value is people who are taking 2 consecutive days off in the morning shift and the afternoon shift. As you all know, this information is the same and it's coming from our yellow cells. I'm going to make a little quick note right here. And I'm going to say 45 people or employees have Monday and Tuesday off. This is important information. You can answer this question by looking at your programming space right here, or you can answer this question by looking at the sensitivity report. The information is duplicated, so it's your choice. Now we're going to move on to the objective coefficient. We know where that information is coming from. This is the cost the price that we are paying to each employee on a per hour basis, or sorry, per weekly basis when they come and work for us. This is a part of our objective function. We're gonna color code it as green. Allowable increase and allowable decrease represent how much more or how much less we can pay each of our employees based on which of the days they're taking off without changing our final solution or final value. This in turn helps us to determine our maximum and minimum wage that we can move around or move in between without affecting our final solution or final value. So I'm going to calculate my maximum wage and my minimum wage using the allowable increase and allowable decrease. My maximum wage is going to be simply objective coefficient plus my allowable increase, comes to 560. I'm going to copy it for the rest of the cells. And my minimum wage is going to be equal to my objective coefficient minus the allowable decrease, because we are adjusting it by subtracting the allowable decrease. How much less we can pay our employees based on which days they're taking off without changing the final value. We go ahead and color code them. Been using orange. For the employees who are taking Monday, Tuesday off in the morning shift, we are paying them $560 per week. And there are 45 people who are taking these 2 days off. We can pay them up to $560, which we're already paying, without changing the final values. Still going to be 45 people taking these 2 days off. It's going to be optimal solution for us. And we can reduce their wage up to $520 without changing the final value. There's still going to be 45 people taking those 2 days off, and it's going to still be our optimum solution. Now you must be wondering, there are some maximum wages right here. I'm highlighting them right here that are infinity. You don't have to worry about these, but because if you see in your final value cells, for all those days or consecutive days where nobody's taking those 2 consecutive days off, our maximum wage is infinity. Anything multiplied by 0 is 0. So that's Excel's way of telling us doesn't matter how much you increase the wage for those 2 consecutive days, nobody's taking those 2 days off. So basically nobody is utilizing those 2 consecutive days as their holidays. Now let's move on to the constraints table and see what it's telling us. Again, the final value in the constraints table is the left-hand side of our constraint, which we've already determined. And let me color code it. It's blue. This is the actual number of people who are coming to their morning shift on Monday. So just to make a note of it right here, this is 55 people are coming to work on Monday morning. And the interpretation for the rest of the cells is gonna be the same. The right hand side of the constraint is again the right hand side of the constraint as we have set it up previously, and I'm going to color code it as red. So basically our demand for the Monday morning shift is 55, and we are actually having 55 people to come. If you look at the Tuesday, we had a demand for 60 people to come, and then instead there are 70 people coming on that day to work in the theme park. Now remember the point that we've discussed in the previous video. When we have a demand for employees or human resource, it's basically the bare minimum that we need to sustain our operations. If less than our demand are appearing, that can cause operational disruption. So for optimal solution, we always set our constraint in a way that if more people are appearing that day or coming that day, and that still is an optimal solution for us, we'll go for that. The shadow price has the same interpretation as we had before. And let me color code it so it's visible. So our shadow price is our marginal cost. So demand for one of the employee increases for a particular shift in a particular day. Shadow price tells us the wage increase, which is going to impact our objective coefficient or objective function, which is the total cost. So let's go ahead and write this down. So what that means is for Monday morning shift, 55 people are appearing. 0 shadow price means we have to increase our demand for Monday morning shift from 55 to 56. It's not going to impact our total solution or the green cell. Moving on to the Friday, where we have a positive shadow price. If you compare the left-hand side with the right-hand side, we wanted 90 people to come, and 90 people are appearing that day for work. If you would have to increase our demand for that day from 90 to 91 people, let's say Friday we have an additional show in the theme park that needs to be covered, and we want 5 more people, then the total effect of that increase would be 40 multiplied by 5, because we want 5 more people. The demand for our employees have increased by 5. Our marginal increase in our total cost or labor cost is 40. So we're going to multiply that by 5, and that's the total effect on our objective function. Similarly, if you look at Saturday, we want 120 people in the morning shift and 120 people in the afternoon shift. 120 people are coming in the morning as well as afternoon shift, but if you look at the shadow price, apparently, if you would have to increase our demand for that day from 120 to 121, the total cost is going to increase by $480. That's a big jump. Now, before we conclude this video, I would like to highlight 2 points. Throughout this video, if you've been wondering that why my yellow cells are different from this video, please don't worry. As long as your green cell is the same as the one in this video, your solution is correct. When we get different yellow cells every time we run a solver, that means there are more than one possible optimal solutions available to that problem. So you might be getting different yellow cells. Secondly, after looking at all the solution, we know now how many people are actually coming against the requirement for this theme park in the morning and afternoon shift. A good question to answer would be, which days is the best to schedule additional event? Now, in order to answer this question, we would compare our blue cells with the red cell. And if you see, there are a few days where we are having more employees coming against the demand we have. For example, Tuesday is one of those days, Wednesday is one of those days, in the morning shift as well as in the afternoon shift. So we have more human resource than we require. And that can be helpful in determining if we would have to schedule additional events, which days are going to be better without incurring additional costs. And that would be Tuesdays and Wednesdays. Now, if you go back on the sensitivity report, among all the days, we would definitely not want to schedule additional events that might lead to the requirement for additional human resource on Saturday, Sunday, and Friday, because apparently the shadow price is positive, and any increase in the demand might increase or definitely increase our total cost for sure. But that is all about the sensitivity report in the scheduling problem. And if you have any questions, you are more than welcome to contact your instructor, and we'll see you in class.